In today's video, we are going to talk about finding x-intercepts. Now, the nice thing about finding x-intercepts, like finding y-intercepts, is that there is one method that will work for everything. Now, this process is easiest in factored form, for reasons that you'll see in just a few moments. However, you don't have to be in factored form. Okay, so let's talk about the actual method itself. Just like when we were looking for the y-intercept, we are going to take advantage of the fact that we know something about these x-intercepts. So as you can see here, I've put down a parabola that has an x-intercept here and an x-intercept here. Now again, on the diagram it looks like one is positive and one is negative, but don't be distracted by that. Those two could be anywhere. Or there might only be one, who knows? So, the one thing we do know, we do not know this distance here, which would be x1, or this distance here, which would be x2. We don't know either of those things, but we do know that the y value of each of those points must be 0 in order for them to be x-intercepts. Anytime you are touching the x-axis, you are automatically at y equals 0. So we can go ahead and fill in y equals 0 and solve for x. And that is our method. And again, this is true regardless of the kind of equation you're talking about. For a quadratic, for a linear, for an exponential, for any other kind of function, if you want to find x-intercepts, make y equals 0, solve for x. You might get two solutions. We already knew that. In fact, in this particular parabola, you would definitely get two solutions. Okay, so we're going to do some examples, and we're going to start with some easy examples in factored form. So as you can see here, I have three example problems, all three of which are in factored form. And we want to find the x-intercepts. Now remember, our method for finding x-intercepts is always make y equals 0, solve for x. So in this case, I get x minus 1 times x plus 2 equals 0. I have taken y and I have substituted in 0. I've also, if you may have noticed, switched sides. I just prefer to have my x's on the left, but it really doesn't matter. You can have them in whichever order you want. As we discussed in class, we right now have two factors that multiply together to make 0. Anytime you have two factors multiplied together to make 0, one of them has to equal 0. There are no two non-zero numbers that you can multiply together to make 0. One of those two factors has to be 0, and because there's two of them, there are two possible answers. Either x minus 1 can equal 0, or x plus 2 could equal 0. Again, if this thing right here, x minus 1, if that were to equal 0, then it doesn't matter what the other factor is. The whole thing multiplies together to make 0. So each of these is hopefully a fairly simple one-step equation. Add 1 to both sides, you get x equals 1. Subtract 2 from both sides, you get x equals negative 2. Our two x-intercepts are 1, 0 and negative 2, 0. Let's move on. In this second example, we have f of x equals 3 times x plus 1 times x plus 4. Now, a lot of folks are thinking, what does this 3 do? And the answer is not a whole lot. It is, yes, a factor. It is, yes, multiplying. But 3 will never equal 0. So we don't have to worry about setting that particular piece equal to 0. Instead, what we're going to do, take the same first step, make y equal 0. Remember, f of x and y are the basically two ways of saying the same thing. And we're going to divide both sides by 3. Why would I do that? Because now on the left, the 3's cancel. And on the right, well, 0 divided by 3 is just 0. So I get x plus 1 times x plus 4 equals 0. All right? x plus 1 equals 0. X plus 4 equals 0. Again, two factors multiplied together to make 0. One or the other of them has to be 0. On this left one, we subtract 1 from both sides. We get x equals negative 1. Over here on the right side, we subtract 4 from both sides, and we get x equals negative 4. So our two x-intercepts are negative 1, 0, and negative 4, 0. We'll do one more example of this, and then we'll move on. Take a look at this one on the far right. Y equals negative 2x times x minus 3. Well, this one seems a little bit confusing, but let's take a look anyway. So we get negative 2x times x minus 3 equals 0. Now, some of you are looking at this and going, hold on, wait a second. There is no x plus anything there. It's just negative 2x. Doesn't that change things? And the answer is no. No, it doesn't change anything. The same method still works. We still have two factors multiplied together to make 0. So we're still going to take each factor and set it equal to 0. Over here on the left side, negative 2x equals 0. Divide both sides by negative 2. You get x equals 0. On this side, add 3 to both sides. You get x equals 3. My 2 points are 0, 0, and 3, 0. Now, some of you may have noticed really quickly this relationship between the factored form and the answers. This plus 2, this minus 2, this minus 1, this plus 1, this plus 1, this minus 1. So if you're thinking, oh man, the answer always seems to be the opposite of whatever is in there with the x inside the parentheses, then that's a great thought process, and it's something you should be thinking about going forward. All right, let's move on to vertex form. Now in vertex form, the process is exactly the same. We are still finding the x-intercepts, and we are still making y equals 0 and solving for x. Now the first instinct that a lot of students have is to start expanding this out. X plus 2 times x plus 2, you get x squared plus 4x plus 4, dot, dot, dot. That's not really the way to go here. We want to have only one x, right? We want to have a single x at the end, and we're not going to get there by expanding it out and making it look worse. What we're going to do instead is solve it just like every other equation you've solved since you learned about variables when you were in 7th or 8th grade. So again, we're going to make y equals 0. We get x plus 2 squared minus 9 equals 0. And just like an ordinary equation, I'm going to start from the farthest away point from the x, and I'm going to work my way in. Basically, I'm doing order of operations, but I'm doing it in reverse. In regular order of operations, the very last thing you do is addition and subtraction. So if I'm going to undo things, I'm going to start with addition and subtraction. I'm going to add 9 to both sides. This addition in here is inside the parentheses, which means it will be the very last thing I do, right? In normal order of operations, parentheses come first. So if you're undoing it, parentheses would be the last thing you do. Okay, so I add 9 to both sides. And I get x plus 2 squared equals 9. Now the next thing I want to get rid of is this exponent, this squared. Well, the opposite of squaring is square rooting. All right, well on the left side, the square and the square root cancel out, so we get x plus 2. And then the square root of 9, what number can I multiply by itself to make 9? Well, 3. But there's another one. There is another number that you can multiply by itself to make 9. So x plus 2 must also equal negative 3. Think about it. Negative 3 times negative 3 is indeed positive 9. So both of these answers are valid, which makes sense because, again, you can have two answers to a quadratic equation. Again, solving each bit by subtracting 2 from both sides. we get x equals 1 and x equals negative 5. My two x-intercepts are 1, 0 and negative 5, 0. Let's try another one. H of x equals negative 4 times x plus 6 squared. Lovely. So negative 4 times x plus 6 squared would then equal 0. Again, y equals 0. I'm going to start by dividing both sides of the equation by negative 4. On the left side it cancels. On the right side, 0 divided by negative 4 is still 0. So I get x plus 6 squared equals 0. Again, the way you undo a square is by square rooting. Okay? On the left, the squared and the square root cancel out, so I just get x plus 6 equals what multiplies by itself to make 0? Well, just 0. There is no positive and negative 0, so in this case, there's just going to be one answer. And to find that answer, subtract 6 from both sides, you get x equals negative 6. So the only x-intercept that I have on this parabola is negative 6, 0. So again, sometimes you're going to end up with one solution, sometimes you'll end up with two. All right, last example. F of x equals x minus 3 squared plus 16. All right, well, same first step, set y equal to 0. So we get x minus 3 squared plus 16 equals 0. Okay, next step, subtract 16 from both sides. We get x minus 3 squared equals negative 16. Next step, to get rid of the squared, we square root both sides. But we've got a problem here. The left side's fine, we get x minus 3, that's no problem. But what goes there? What number can I multiply by itself to make negative 16? Well, it can't be 4, because 4 times 4 is positive 16. It can't be negative 4, because negative 4 times negative 4 is, again, positive 16. I think we're stuck. We can't yet take the square root of a negative number, so the answer is no solution. To put it visually, this is a parabola that points upward and has been moved up so it doesn't touch the x-axis at all. All right, we're going to do a couple more examples, this time in standard form, and that'll be the end of the video. So we just showed that you can find x-intercepts in either factored form or vertex form. It's just somewhat easier to do in factored form. So if you are given a problem where you need to find the x-intercept of a quadratic that is not in factored or vertex form, it is probably best to try to put the quadratic into factored form, since that is the easiest way to get those x-intercepts. If that doesn't work, like if the quadratic isn't factorable, you can still maybe figure it out by completing the square. So you want to try factored form first. If that doesn't work, then maybe try completing the square and solve that way. All right, let's do a couple of examples. Okay, for our first example, we have f of x equals x squared minus 6x minus 16. Now, like every single other problem in this video, we are trying to find the x-intercepts. Well, again, the optimal way of finding the x-intercepts is to put it into factored form, so let's see if we can do that. We start by taking the last number here, negative 16, and we need to find two numbers that multiply to make negative 16 and add to make negative 6. And because we just have this 1x squared here, we'll be basically done after that point. Okay, so let's see. Two numbers to multiply to make 16, or negative 16, and add up to negative 6. Well, I can make 16 by doing 1 times 16. That doesn't really help. It's also 2 times 8. Well, that could help, because if I do a positive 2 and a negative 8, positive 2 times negative 8 is indeed negative 16. Positive 2 minus 8 equals negative 6. So I'm left with f of x equals x plus 2 times x plus 8. And again, you could absolutely double check and make sure that you did this right, and in fact I didn't do it right. You can absolutely double check and make sure that you did this right by multiplying them together using FOIL or distribution, and check to see that it comes back to what it was supposed to be. And again, because we have two factors that are multiplied together to make 0, we're going to set each one equal to 0. So our two x-intercepts are negative 2, 0 and 8, 0. Let's do one more example and then we'll end the video. Okay, in this second example, we have y equals 3x squared plus 8x minus 3. So we're going to set it equal to 0. We're going to set y equal to 0. Well, to start with, we've got this 3 out in front of the x squared. That's mucking things all up. It's making it more difficult than it was last time. And also, I noticed that I can't just divide the 3 out of all 3 of these terms because of this 8. Okay, so I guess I'm stuck going back to factoring by grouping, which is the very last factoring technique we used. We start by multiplying a times c, which is 3 times negative 3, which is negative 9. Same deal. We need two numbers that multiply to make negative 9 and add up to make positive 8. Well, 9 is 9 times 1, and if I make the 1 negative and the 9 positive, negative 1 times 9 is negative 9, and negative 1 plus 9 is indeed positive 8. Now again, because we have that 3x squared, we have to be a little bit more creative here. We can't just go straight to the answer. We have to split our middle term. So we get 3x squared minus 1x plus 9x minus 3 equals 0. Notice that we have not changed anything. That's 8x. That's 8x. We just kind of uncombined like terms. Our next step, split this new quadrinomial in half. What can I factor out of the first two terms? Well, all I see is an x. 3x squared divided by x is just 3x. Negative 1x divided by x is negative 1. Don't forget that we're adding these together. In this second two terms, I see a 3 that I can divide out. 9x divided by 3 is 3x. Negative 3 divided by 3 is negative 1. As you can see, we have these matching terms, which is what we need. We're going to factor the 3x minus 1 out, so we get 3x minus 1 times what's left over, x plus 3. We are now in factored form, and we are almost home free. Take each piece. 3x minus 1 equals 0. X plus 3 equals 0. Again, because if either one of those factors equals 0, then the whole product equals 0. The right one's easy. Just subtract 3 from both sides, and you get x equals negative 3. Over here, it's 2 steps. You get x equals 1/3. So our two x-intercepts are 1/3, 0, and negative 3, 0. So that's it for x-intercepts. The basic idea, make y equals 0, solve for x. The actual mechanics of solving for x might vary from problem to problem, but the basic idea, make y equals 0 and solve for x, is consistent for every single x-intercept that you'll ever find. Thanks for watching, and I'll see you in the next one.